Hello everyone. We are on to section 10.2, day 2 today. Hopefully you're doing okay with your homework so far. If you're having trouble or still not able to figure something out, please make sure that you let me know. And please make sure that you're uploading your assignments every day like you're supposed to be. All right, so 10.2, day 2. We're going to finish off our work with parabolas. And there's one specific problem that we're looking at today. So before we get into dealing with the reflective property and then finding the tangent line at a point on a parabola, we're just going to do a quick review problem. So just like we did yesterday, it's going to ask us to find the vertex, focus, and directrix of this parabola and then sketch its graph. And remember, like I said yesterday, whenever you're given a parabola, the first thing you should do is see if it's in standard form, and I can see that it's not. When I look at this, I notice that I have a y squared term and a regular y term. If you remember what we said yesterday, that also means that not only is it not in standard form, but I have to complete the square to do that. So what I'm going to start with is I'm going to get the term that's not a y term and move it over to the right side. So I would have y squared minus 4y is equal to, that would become positive 4x. And then this is the b value, it's negative 4. So take half of that number, square it, and remember we said that we were going to add it to both sides. So half of negative 4 is negative 2. If I square negative 2, I get 4. It looks like I'm going to be adding 4 to both sides. And just like we said yesterday, it's okay for us to do that because we're adding the same number to each side, so we're keeping the equation balanced. If we do this correctly, this should now factor into a perfect square. It's going to factor into y minus 2 quantity squared is equal to, you always take out whatever this number is regardless of whether they have it in common or not. Thankfully, they do have it in common, so it makes it a little easier for us. And now I've got the parabola in standard form. So that's kind of the first step of doing this problem, is make sure I have it in standard form. Now that it's actually in standard form, I'm going to go ahead and graph it. And like we mentioned yesterday, you don't have to make tick marks and make this extremely accurate if you don't want to. As long as you have the vertex point in the right spot and it's opening the right direction, that's all I'm really looking for. So when I look at this problem, I notice that it's the y that's being squared. So I know this is going to open to either the right or to the left. I look at that number, it's positive, so I know this parabola is going to open to the right. So the vertex point, if I set my parentheses equal to 0 and solve, there's where the x variable is. So set that one equal to 0 and solve first, you get negative 1. Set this one equal to 0 and solve, you get positive 2. There's my vertex point. It's at negative 1, positive 2. And like I said, in terms of, for the sketching purposes, I know it's opening to the right. That's all I really care about. Now for finding the rest of the material, the focus and the directrix, it might be helpful to look at this. I know the focus is going to be somewhere over here. It's to the right of the vertex point. And assuming that we remember what we were doing yesterday, we take this number, whatever this is, and remember that's going to help us figure out what p is. So that number, we always said equal to 4p. Divide both sides by 4, I find out that p is 1. And we said yesterday that that's the distance from the vertex point to the focus. Since we are moving to the right, we are going to add 1 to the vertex point. And we're going to add it to the x value. So our focus is going to be at the point. If I move 1 to the right, that's going to give me 0. And that makes sense if I look at my picture. 1 to the right, that would put me at 0, 2. Again, the y value is not going to change. So now I've got the focus. Next thing I do is find the directrix. If I moved 1 to the right to get the the focus, I would move 1 to the left to get the directrix. So now subtract 1 from that, and that's going to give me the number I need for the directrix. Remember, the directrix is a line, so I don't write it as a point saying negative 2, 2. I write it as x is equal to negative 2. If you look at the picture, you can tell that this would be a vertical line, and we're dealing with just the x value. So there's my focus, there's my vertex, focus, and directrix. And again, good example to make sure that we're okay with what we did yesterday. All right, so now on to the new main idea for today. It's thankfully just one main idea, and we'll do 2 examples of it. It starts out with the reflective property of a parabola. It says the tangent line to a parabola at a point P makes equal angles with the following two lines. So here's my parabola. Here's my point P. Point P can be anywhere on this parabola. I just happen to pick that. If you remember what a tangent line is a line that touches the parabola at one point. And that's that point P that we're referring to. So this is actually the tangent line. We eventually are going to be finding the equation of that. But for this property, it says the tangent line of that parabola makes equal angles with the following two lines. The line passing through P and the focus. So that would be this one. Here's the line passing through P and the focus. That's number one that it's referring to. And then it says the axis of the parabola, or axis of symmetry. That's this. And so when I look at this, they're saying the tangent line and those two lines are going to form a triangle. And that triangle is giving you angles of this angle and this angle that are the same. That's what this property is trying to say. So I don't need to have that property memorized or anything. It's not that important. But I need to understand how that works, how these angles are the same, because that's what I'm going to do when I find the equation of the tangent line. I have to use that idea. So that's what the reflective property of a parabola is. And I'm going to use this picture to kind of walk us through what these steps are. So the next two examples that we do are going to ask us to find the equation of the tangent line at a specific point on the parabola. So we go through the same 4 steps every single time. Step number 1 in this process is find the focus. So when you're given a parabola, whether it's in this form or whether it's actually in standard form, first thing you want to do is figure out what the focus is. So you're going to find the vertex point. You're going to take this number, divide by 4 so you can figure out what P is, and then you're eventually going to come up with that focus. So it could be a quick little step, or it could take a little bit longer depending on how much work you have to do. But there's step number 1, find the focus. All right, now that I've got the focus, step number 2, find the distance from the focus to the point that you were given, so point P. They want you to find this distance. And of course, if you have 1 point here and 1 point here, you're going to use the distance formula. So when you're doing step 2, in case you've forgotten, the distance formula is going to be the x values subtracted and then squared, plus the y values subtracted and then squared. And you probably remember that because you used it yesterday. All right, so find the focus, step 1, find the distance, step 2. All right, so step 2, why did I do step 2? It's so I can do step 3. It's saying from the focus, so from right here, we're going to move that same distance. So let's just say that this distance here happened to be 8. That's what this distance is. We're going to move that same distance opposite the direction the parabola opens. This parabola is opening up. So we're going to move 8 down, opposite direction. And remember, we're moving from the focus. That is very important. So from the focus, move the same distance, the opposite direction the parabola opens, to find what I call the second point. So from that focus, if this distance is 8, I'm going to go down 8. And what that should find is that should find this point here, where the tangent line and that axis of the parabola intersected. This is the second point. The book doesn't call it anything, and that's as creative as I can get, is to call it the second point. So step number 1, figure out where the focus is. Step number 2, find the distance between the focus and point P. Step number 3, move that same distance down. Why can I do that? Because these two angles are the same. Because those angles are the same, that means these two distances have to be the same. So if I move 8 this direction, I can move 8 down. If your parabola was opening to the right, opposite direction, you'd be moving to the left. Or if your parabola was opening down, opposite direction, you'd be moving up. So very important. So on that step, the two things that people make mistakes on is that they don't move the right direction, or this is important, from the focus. It's very common for people to move from the vertex point. All right, assuming that you did step 3 correctly, you should now have this point. And now if you look at this blue tangent line here, you have point P, which is on the tangent line. You have the second point, which is on the tangent line. You now have 2 points that are on the line. Now step 4, use the given point P and use that second point that you just found and write the system, or sorry, not a system of equations, write an equation of a line, finding the slope and y-intersect. So your y equals mx plus b. So 4 steps. When you've been writing down your equations on a certain sheet of paper, you're going to want to make sure that you write these steps down. You should be able to recite these steps in order with no problem. Probably not right now, but eventually, of course. So the good news is the same 4 steps for everything. So let's try a couple of examples of doing this. Let's try the first one here, where it says find the equation of the tangent line to the parabola given by, and then they give me my equation, x squared is equal to 2y, and here's the point that they want me to deal with. All right, so before we do anything, I know that step number 1 says find the focus. Well, in order to find anything particular on an equation of a parabola, I need to make sure that that's in standard form. So I don't see the parentheses squared, and that's okay. I don't see a parentheses squared, but do you notice there's no other x term? There's an x squared, but there's no x. That means this is the same thing as saying x minus 0 squared. There's no parentheses with the y term. This is actually the same thing as 2 times the quantity y minus 0. So I now have y minus 0 quantity squared is equal to 2 times the, sorry, that's an x. X minus 0 quantity squared is equal to 2 times y minus 0. That's actually in standard form. You don't have to rewrite it like that. It's just if you want to. Again, you don't have to draw a picture if you don't want to. I like it because it helps me to picture things, helps me to see what I'm doing. I know my vertex point is at 0, 0, so it's right here. And I know based on this number being positive that it opens up because it's x that's being squared. So I have a parabola that ends up looking something like that. So now that I see that I have a parabola and that it opens up, I have a better idea in terms of what it looks like. All right. Don't mind the noise in the background, it's just the cat feeder. All right, so when we move on from here, step number 1 was to find the focus. All right, so that means now that I've got the vertex point, which is here at 0, 0, I need to look at this number. So I need to figure out what is P. P, remember, is going to be a fourth of this. We always set 4P equal to that number. So P is actually equal to 1/2. Based on the fact that this parabola is opening up, that means I need to go up 1/2. And since I'm going up, that means I add it to the y value. My focus, step number 1, is the point 0, 1/2. So when I'm looking at your homework or say that that was a test question, that's the first thing I'm going to be looking for, is did you give me the right focus? If you make a mistake and you think your parabola is going to the right and you say it's 1/2, 0, then of course I would say, oh, there's your one mistake. I'll follow the rest of the work from there on out. All right, so there's step 1. I got the focus. Step number 2, which remember when we say to study, you should try to say that step without looking at it. For now, you'll probably have to look back at it. But it says find the distance from that point to the point they gave me. Now this point 3 and then 9/2, if I think about it on the graph, 3, 9/2, that's probably over here somewhere. They're asking me to find this distance. So step number 2, find the distance. Distance is going to be square root of, here's one point, here's the other. It's the difference in the x values. So either 3 minus 0 or 0 minus 3 squared, plus the difference in the y values. You can now see where that fraction actually is to our benefit. Let's say 9/2 minus 1/2, or you can do it the other way around. Doesn't matter because we're squaring it. And that's going to give me the square root of 3 squared, or 9, plus that's going to give me 8/2, or 4. So 4 squared, so 16. Which means my distance is the square root of 25, or 5. There's the second thing that I'm going to be looking for when I'm looking at your work. Now, in terms of doing these problems for homework or quiz or wherever you might see it, this is the step that you can check to see if you've done things correctly. When you get to step 2, if this number is not a nice number, so an integer, should be no radicals on it. If it's not, you know something's wrong. So if you get to the end here and you say that your distance is 5 squared to 3, something's wrong. You've made a mistake. Either your calculation here is wrong or your focus is wrong, but something is wrong. If you're in the middle of a test and you get this number and you double check this 2 or 3 times and you can't find the mistake or you don't have time, you'll have to move on with this problem. I would say a recommendation would be to approximate it to a decimal. All right, there's step 2. On to step 3. So we found the focus, we found this distance. Now, if I actually drew the tangent line in through that point, it would look something like this. What we're trying to find next is where these 2 points are intersecting. So if this distance is 5, I'm going to move this distance 5. I'm looking for this. You can see I need to move down 5. My parabola opened up. I moved down 5 from the focus. So if my focus is 0, 1/2, and I need to move down 5, remember that means I needed to subtract 5 from the y value. So this second point, or you can call it whatever you prefer, since that's not overly creative. If I subtract 5, it might be a good idea to get a common denominator. I have 1/2 minus 10/2. It looks like it's going to give me the point 0, negative 9/2. There's my second point. There's the third thing I'm going to be looking for. Did you get that second point correctly? So again, up to you if you want to draw a picture. I recommend it. It's easier to picture when you can, it's easier to see things when you've got the picture right in front of you. I can see if that's the focus and that's the distance. I'm going to have to move down to get that point of intersection. Now I'm at step 4. Take the point that they gave you and the second point and come up with the equation of a line. So I'm going to use the point that they gave me, which was 3 and 9/2. And now I'm going to use the second point, which is 0 and negative 9/2. And I'm going to come up with the equation of a line. So I'm going to find the slope and y-intercept. Now remember over here, when we said it doesn't really matter the order because you're going to end up squaring it, it does make a difference in the order when you're finding the slope. So I'm going to start with this point first. So when I do y value minus y value, it's going to be 9/2 minus a negative or plus 9/2 divided by, it would be 3 minus 0. Again, you can do it the other way around. You can start with this point. Just make sure you start with both of the y and the x. If I add my numerators together, I get 18/2, or that's 9, divided by my denominator would be 3. Looks like my slope ends up being 3. So I can say the equation of my line is y is equal to 3x plus b. I don't know what b is, so I can pick one of the 2 points and plug them in. Now, it just so happens that this is the y-intercept because the x value is 0, so I actually know that b is negative 9/2, but chances are you wouldn't know that, so you're going to have to pick one of the points and plug it in. So yes, I know that it's negative 9/2, but to show you that it's going to work, I'm going to plug in this point, even though it's not the easier way to do it. So plug in 9/2 for the y value, plug in 3 for my x value, and if I do a little bit of simplifying here, I have 9/2 is equal to, this is 9 or 18/2, and if I subtract 18/2 from both sides, you can see that, yes, sure enough, b ends up equaling 9, negative 9/2. So my final answer, the equation of the tangent line, is y is equal to 3x, and then instead of plus b, I'll say minus 9/2. And there's your final answer. It's a process that once you get used to doing it and you do it a handful of times, especially if you know your steps, it makes it way easier. But you do it a few times, you start to get used to it. But like I said, step 2, this is your check. If you don't get a nice number, an integer here, you know something's wrong. The odds of you doing this incorrectly, something, and having a nice number are slim. All right, so same type of problem, just going to practice it again. This time they give me a parabola that's not in standard form. So I know that that's my first step to do. So I have to ask myself, should I complete the square or not? And of course, you are hopefully looking at it saying I have a y squared term and I have a regular y. So yes, I am going to have to complete the square. These two things are going to get moved over to the right side. So I'm going to have y squared minus 2y is equal to, I'm subtracting the 8x and subtracting the 9. I now go to my step of take the b value, divide it by 2, and square it. So if I take negative 2, divide it by 2, gives me negative 1, and then square it, I realize that I'm adding a positive 1 to both sides. And then if I did that step correctly, I should be able to factor that. I think we've talked about the trick in factoring. Most of these are pretty easy to factor, but in case you get one that you don't recognize how to factor it, because there's fractions and weird numbers in there, it's always half of this number. Make sure you pay attention to the sign. Notice that's negative 1. All right, if I add like terms on the right side, it looks like I have negative 8x, and that gives me minus 8. I've already got the left side the way I want it. It's y minus 1 quantity squared is equal to, I have to factor out the negative 8, the number that's in front of x, and it looks like it gives me x plus 1, so now I've got it in standard form. Like I said, up to you. You don't have to graph it. I like graphing it. You don't even have to be that good at graphing it. You don't have to plot points you don't want to. For me, it's more so I have a picture to look at so I know what direction I'm supposed to be moving. In terms of graphing this particular one, it looks like my vertex point is at -1, +1. So it would be right here, approximately. I know that because y is squared, this is not opening up or down, it's left or right. And because of that -8, it is opening to the left. So I know my focus is over here somewhere. The point that they gave me, -1.5 and 3.3, -1.5 and 3 from here. -1.5 would be over here, 3, it's right around there somewhere. That means my tangent line looks something like this. The axis of symmetry looks something like this. This is the point that I'm trying to figure out. That's what my quote-unquote second point is. So, using that picture, using my equation, I'm now going to find the information that I'm looking for. We just got done saying that the vertex point was at -1, 1. Now you ask, is it a good idea to list that out? I would say yes. In terms of showing your work, I need to see that. I need to know where that is. It helps me to be able to identify whether you're going the right direction. All right, there's what 4p is equal to. That means I know p is equal to -2, and I can see on my picture, since I graphed it accurately, I'm going to the left, so I should be subtracting 2 from that number. That means step number 1, my focus is going to be -3, 1. There's the first thing I'm looking for. Step number 2, if I look at my picture, there's the focus, there's point P. I need to know what's this distance. So there's point P, there's my focus. I need to go ahead and use my distance formula to figure out what that's going to be. So let's just come up here and do it. So distance is equal to square root of, got fractions again. I'm going to go with -3 minus a negative, so plus 3/2 squared, plus 1 minus 3 squared. And yes, you probably want to get a common denominator. I know that that's going to be -6/2 plus 3/2, or that's really -3/2 inside the parentheses. Squared, plus that's going to give me -2 squared. And if I square that fraction, I'm going to end up with a positive 9/4 plus, now I know that -2 squared is 4. I'm going to change that to 16/4 because, again, I want a common denominator. And when I add those together, they have a common denominator, so I can say it's 25/4. And like we said up here about how it has to be a nice number, notice if you take the square root of both of those numbers, it ends up giving you a nice number. Or at least it gives you something that's not a radical. So up here I was saying it needs to be an integer. Well, it's not quite an integer, but that's what I meant by nice number. It just can't be a radical. All right, like I said, because I got a nice number here, I know the odds are that I've got this right. At least I've got the first few steps right, because it doesn't usually work out nice if you don't do that. So if I know this distance is 2.5, that means I should move 2.5 this distance to come and get this point. And I can see on my graph, that means I need to move to the right. Parabola is opening to the left. I need to move to the right. And remember, I'm moving right from the focus. So I'm going to move right 2.5 or 5/2. That means I need to add it to the x value. So my second point is going to be, if I add 5/2 to that, it's going to give me -1/2, comma 1. There's my second point. There's my third step done. And now my last step, take my second point and my point P that they gave me and use those two to find an equation of a line. So I'm going to write those 2 points down so that I've got them again. It's -3/2, 3, that's point P, and then my second point was -1/2, 1. And now if I come up with the equation of the line, I'm going to say the slope is equal to y value minus y value. I'm going to start with this one. I'm going to say it's 3 minus 1 divided by, that means I need to start with the -3/2, minus a negative, so plus 1/2. And finding my slope, it looks like I have 2 divided by, that's going to give me -2/2 or -1. So my slope ends up being -2. And if I drew my picture accurately and you come back and you look at it, you'd say, yeah, that makes sense. I've got a slope that's a negative number. So I have y is equal to -2x plus b. And if you look back at both of these points, neither one of them is the y-intercept. They don't have an x value of 0. So I actually have to plug one of the numbers in this time. I'm going to pick this point to plug in. Like I said, it doesn't make a difference. You'll get the same answer regardless. So I have 1 equals -2 times my x value, which is -1/2, I would have 1 is equal to, multiply that together, that gives me 1, and looks like b ends up being 0. So the equation of the tangent line is y equals negative 2x, and you don't have to say plus 0, but you can if you want. And there's the equation of my tangent line. I will warn you that the book likes to put it in general form, so they'll probably add the 2x over and say it's 2x plus y equals 0. You don't have to do that. Just like this one, the book will probably move the y over and multiply everything by 2. That's not something you have to do. Just saying that so when you check the answers, you're not freaking out that you got the wrong answer. All right, that's 10.2, day 2. Again, feel free to email questions if you have them. Make sure that you are keeping up with your homework. If you have anything else you would like to know, again, feel free to email me. We'll still be following the same schedule that you see on Schoology, so pay attention to that if you want to know when quizzes and tests are coming up. But the only thing that you should know for this, the main idea, is how to find the equation of the tangent line of a parabola. All right, hopefully everything is going well. Miss you guys.